to talk about solving an exponential equation by finding common bases where we have linear and quadratic exponents. So these equations look really complicated when they start, but they're not actually that bad. The thing we need to look for is a common base. So in this first equation, if you look on this side, we see a 6 as our base, and on this side we see a 36 as our base. So if we can change the base of this one to 6, then we can solve it easily. So 36 is 6 squared. So 6 squared is the same as 36. And then we have it to the 9x plus 2 power. And that equals 6 to the x squared plus 20x minus 20 power. And if you remember, a power to a power, we multiply powers. And if the bases are the same, and they're equal, then the exponents have to be equal too. So we can take these exponents out. So we can get x squared plus 20x minus 20 equals 2 times 9x plus 2. So here we have 18x plus 4 equals x squared plus 20x minus 20. Now, as with all quadratic equations, we want to set it equal to 0. So we can take away 18x and 4 from both sides. So we get x squared plus 2x minus 24 equals 0. So we can factor that into x plus 6 and x minus 4. That equals 0. And then x plus 6 equals 0, or x minus 4 equals 0. So x equals negative 6, or x equals 4. And that is it. Okay. The second one we can solve in a similar fashion. So 64 and 4 are the bases, and we need to find a common base. So luckily 64 is 4 to the third power. If we weren't so lucky, we might actually need to change them both to base 2, and that would work also, but it would be a little bit extra work. But in this case, we can just change 64 is 4 to the third power. Power to a power, you multiply powers, so this is 2 minus 3x equals 4 to the x squared minus 12x minus 15. So here we have 6 minus 9x equals x squared minus 12x minus 15. And then we're going to subtract 6 and add 9x to both sides. So here, this is 0, and this is x squared minus 3x minus 21. And let's see. That doesn't seem like it's going to factor very well. We may need to use the quadratic formula here. So in this case, it doesn't seem like this is going to factor. I mean, 21 is 7 times 3, but that's not going to work for the 3. So we may need to use the quadratic formula here. So the quadratic formula is x equals negative b, so 3 plus or minus the square root of b squared, which is 9, minus 4 times a, which is 1, times c, which is 21, all over 2. So x equals 3 plus or minus the square root of, let's see, oh, sorry, this is negative 21, so 9 plus 84 all over 2. So this is x equals 3 plus or minus the square root of 93 all over 2. And this would be your final answer because the square root of 93 does not simplify. Actually, maybe it does. Let me see. 93 would equal 3 times 31. No, that doesn't simplify. So it's 3 plus or minus the square root of 93 over 2. And that is how you solve an exponential equation, by finding common bases with linear and quadratic exponents.